The Mandelbrot set is a picture called a fractal. To determine whether a complex number I belongs to the Mandelbrot set, one needs to use the equation f of z is equal to z squared plus I. So here we have two parts. z3 is equal to this equation. z6 is equal to this. And they're asking for the value of z3 and z6. So all I want to do is I want to simplify this equation and then simplify this equation. So, looking at our first part here, this was very similar to a warm-up question that we had. Do not distribute that 2. Don't do it. That's a huge common mistake. Instead, this is equal to -1 plus I times -1 plus I plus I. Don't distribute the square term. Think of it like, I know that 5 squared is the same thing as saying 5 times 5. So -1 plus I squared is the same thing as saying -1 plus I times -1 plus I. Okay, so from here we can distribute. So I'm going to take my -1 times -1 gives me a +1. -1 times I gives me -1I, or I'm just going to say minus I. I times -1 gives me minus I, and I times I gives me plus I squared, because I'm multiplying two i's together. We always get rid of I squared as soon as possible. I squared is equal to -1. And then don't forget this plus I out here afterwards, so we're going to combine like terms. So I have 1 minus I minus 1, that whole -1 replaces the I squared, plus I. From here we combine like terms. So if I have a negative, and I can just imagine this is -1I, -1I. So -1I minus 1I gives me -2I. So 1 minus 2I. Combine those. And then I have this plus I here. So this -2I plus I gives me a minus I. And 1 minus 1 is 0. So these cancel out. So all I'm left with is minus I. That was the answer to part A. Part B, we were trying, and that was z3 was equal to -I. Part B, z6 is equal to -I squared plus I. So we're trying to reduce this. -I times -I gives me +I squared. I squared is equal to -1. So this turns into -1 plus I.